So this is the third problem on hydrodynamic lubrication. This is the problem which was asked in GTU. Calculate the maximum radial load, that is W, that the journal can carry and operate at hydrodynamic condition for the following data of a full journal bearing. Journal diameter D is 60 mm, bearing length L is 60 mm, radial clearance small c is 0.06 mm, minimum film thickness is 0.006 mm, journal speed is 1440 rpm, viscosity of lubricant mu is 20 centipoise. Cp means centipoise, you have to convert it into Newton second per mm square. Specific gravity, specific heat values are given, and you also have to find out power lost in friction. Now if you see the given data, length is 60 mm and diameter is 60 mm. So L by D ratio is going to be 60 upon 60, that is 1. So in the table of dimensionless performance parameters for full journal bearing with side flow, that is table 16.1 in Bhandari design data book, L by D ratio 1. Now if you see, clearance C is given 0.06 mm and HO is given 0.006 mm. So HO and C values are given. So I'm going to calculate HO by C, and if you do the division, I'll get the value 0.1. So table you have to refer HO by C 0.1, and in front of 0.1 all the other values you are going to note it down. Like Sommerfeld number S, you can see beside 0.1 you can directly see it is 0.0188. If you see R by C into F value in front of 0.1, it is given as 1.05. So that is where you are going to note down the values. Coming back to the given data, N is 1440 rpm. If I want to convert it into revolutions per second, I have to do 1440 divided by 60. So it is 24 rps. Mu, coefficient of viscosity, is given in centipoise. I'll multiply into 10 raised to minus 9. So I'll get 20 into 10 raised to minus 9 Newton second per mm square. So if I see L by D ratio 1 and HO by C 0.1, in front of that 0.1 value, you can see at the top of the table S is given 0.0188. R by C into F value in front of 0.1, I'm going to get 1.05. Similarly, Q upon RC NSL, I'm going to get 4.74. So S, R by C into F, and Q upon RC NSL, that is coefficient of friction variable and friction variable, CFV and FV, I found out from the table. Now S is given from the table, so I can write down the formula of Sommerfeld number, which is R by C whole square mu ns by P. I only don't have the value of pressure. Remaining all the values I have in the given data. So I'll just put down all the values and I'll get pressure as 6.383 Newton per mm square. Similarly, pressure is force upon area, that is radial load W upon area L into D. So I can just do the cross multiplication and find out W, which is pressure into length into diameter. Pressure I already found out 6.383. L and D are given 60 into 60. So I found out radial load as 22978.723. Similarly, coefficient of friction variable CFV is R by C into F. From the table, I found out the value as 1.05. I have the value of R as 30 and I have the value of C as 0.06. So I just can find out by cross multiplication the value of F, which is 0.0021. Now I want to find out the value of coefficient power lost in friction, which is kilowatt F. The formula is 2 pi ns FWR. 2 into pi into ns is 24. F I already found out right now 0.0021. W I found out 22978.723, and radius R is given 30. So I'll get the value as 0.218 kilowatt. If you like the video, please do like, comment, subscribe. Thank you so much.